Jason Johnson here with ABS Supply. Welcome back. This is a follow-up to our previous video where we talked about pressure hold and pressure release pot troubleshooting with pneumatic controls. Now we've got an example here today of a pressure hold pot and a pressure release pot in electric controls. Very similar outcomes, very similar things, a couple new twists that we're going to go through and explain. Give you some real-world answers to real problems. So if your pot's down, don't panic. Watch this video or give us a call. We love to talk to people. Do it every day. So let's start out with the very basics. What is the difference between a pressure hold, pressure release? You watch some of my videos. I go through it all the time. But it bears repeating because it's very important. A pressure hold pot like this one right here, basically it's the valves is the only difference. At this one, it has valves that shut the air off at the bottom of the pot so the pot stays pressurized when we start and stop. With the pressure release pot, like on my left here, this one shuts the air off in front of the pot. So every time we stop blasting, the whole pot depressurizes and then causing it to repressurize again when you start to blast. It's always more efficient when you can use a pressure hold pot. Always. The valves are a little more expensive, but if you do a lot of blasting, it can really pay off in the long run. So let's talk about what we're doing here. Troubleshooting. My pot's not working. I'm frustrated. I don't know where to go. Let's start with this one. Right over here with their pressure hold. Number one thing with any pot, no matter what you're doing, I don't care what color, what brand, pressure hold, release, pneumatic, electric, check for leaks. It's the number one most common reason that shit doesn't flow. So where does this pot leak? Well, we got a couple of them. We have our exhaust, which is a simple valve valve. Usually pretty easy to check when you pressurize the pot if it's leaking out of there. The second place is the hand access in the side and the pop-up and O-ring in the top. So those are your three common places that you can see leakage. Let's check if it's a power source or let's check if it's a pneumatic valve function issue. So if we just grab our Deadman and click it, you should hear this solenoid, whether there's air to the pot or anything, you will hear this solenoid firing. If we do not hear that click on this solenoid firing to try and operate, we got a power source problem or we got a plug problem or something there. We need to track it down. So we need to start with our battery and kind of go through and see where it is. It could be between the battery and here, or it could be between here and the Deadman. Very simple to track down and start checking connections, doing things like that to see where we get it. Next thing, we got this clicking, so we know it's working. Everything's going good. But is air actually coming out of it? We're getting the electric signal. Is this mechanical valve working? Simple check. We just take this fitting off right here. And by clicking your Deadman switch, what you're going to do is when you're on your Deadman, air is going to come out of here. When you're off your Deadman, there should be no air. If it's leaking, not getting signals, it's that simple. Air out when you're holding the trigger, air stops when you let go of the trigger. If we get that far, now we know we have our electric signal working back to our solenoid is firing, and we are getting air on demand out to the bottom. So now what happens? The next question when we get that far is, why is it not working? Are you getting all air? Are you getting all grit? Or are you getting nothing? Well, the likelihood of air coming out of here and getting nothing is very slim, because that means two valves would have had to fail at the exact same time. Usually doesn't happen. This is the valve that all our air goes through, and the valve at the bottom is where all our grit goes through. If we're getting all grit, like chugging, puking, slugging out, that means our grit valve at the bottom is hung open, but we are not getting air to balance it out. Vice versa, if we get all air but no grit, potentially the grit valve is not opening. So we've got a few ways to check this, starting with the grit valve. In some of my other videos, we have taken the knob off of the grit valve, put a pencil, a screwdriver in there. You can see this on our channel. Try that. Put that in there, hit your Deadman trigger, and see that screwdriver will pop up about 1 inch. Stay open if it's working correctly. If it is not, we might have a seize in the valve. We've got to take that valve off, check it, look for it. But if it's operating correctly and opening, then we either have a physical block or something other like that in the pot we've got to check, because if the valve opens and nothing comes out, we've either got a leak in the pot or we've got a physical clog that we can then address and deal with. It's pretty easy to check and see if this is opening and closing. You will get a little burst of air through here out the exhaust when you let go. it starts and stops. But likewise, you will get full air if that is opening. And a little trick, you could take this choke valve and you can isolate this. So if I hit the Deadman like this, I should get no air. And if I hit it like this and I get air, now we know it's working because I physically blocked off that valve to start and stop. Now let's go over to the pressure release pot. Talk about that electric. Very similar to the other one. Here again, if you remember, what's the very first step we do? We're going to check for leaks in the pot. It's a little bit harder to do with the pressure release pot because I need two people, or I need to be holding the hose right here and checking for leaks at the same time. Because with this pot, like we said, the pot does not pressurize until you're on the trigger. So it's easiest to have someone go hold the trigger and you check for leaks. Look at the pop-up in the top. Look in your manway in front. Look at this exhaust hose. That is a wear point. It's going to start to wear at some point. This hose is going to break down and get a hole in it. Very common spot. Check those three places for leaks. That's your number one step. Step two, we're going to repeat the same thing with the electrics that we did over there. We are going to hit our electric trigger and we are going to look and check by when I push this trigger if I get this to click. Hearing this click tells me I'm getting power from my battery. No click, no power from the battery. We've got a connection, a problem, an issue, something we have to track down between here and our 12-volt source. If we get to the point where we're hitting this to click, we have no leaks in the pot, then we want to check to see if the physical function of this valve is working. That's where we remove this from the bottom of the valve, and we will check to make sure that when I hit the Deadman trigger, air is coming out, and when I let go of the Deadman trigger, no air is coming out of the bottom. That will tell me whether this valve is functioning or not. So once we've gotten this far in the system, there's not much else because the grip valve at the bottom doesn't move. It's either open or it's not. So if no grit is coming out, we probably have a clog or a physical thing because that grip valve is always open. It doesn't mechanically open and close in a pressure release system. And if we've got no air screaming out of here, we should be getting a good seal in our pot and everything's good. Less things to troubleshoot, less to go wrong. Simpler style of pot with pressure release than with the pressure hold. Before I go, you might have been asking yourself, why do we have regulators on these pots? What's going on with all this extra piping? These pots are set up, both of them, to do the same thing. They allow the operator to blast at low pressure. So if I've got a delicate piece of wood or light gauge metal or something like that, and I want to be able to turn my pressure down, these valves take anywhere from 70 to 80 psi to operate them. So if I don't have that much pressure in my airline, if I've turned it down to 40 psi to blast cedar-sided house, I don't even have enough pressure for my valves to work at all. So nothing will work regardless of how well maintained your system is. But you'll notice in both these systems, we have taken the signal layer that runs all our valves upstream of the regulator. This means that all of our operating valves that function to start and stop our blasting system, they're all running off full 100 psi from your compressor, allowing us to turn the blast pots down to 25, 30, 35, 40, pick a number, low psi, and blast. That's how we were able to do it. So we maintain high pressure to all our control valves, signals, and then we can shut the pressure down and blast low pressure with the pot. Great pro tip to take any pot and make it more of a multi-use pot to do anything with is add a regulator with the air source upstream of it so you can continue to blast at low pressure while your valves operate. Thanks for watching this video. Hopefully this helped you out of a jam. And if not, pick up your phone and give us a call. We'd love to talk applications. Jason Johnson with ABS. And as always, have a blast.